Hello, mentors. Let's talk a little bit about this puzzle called Paint It. And remember, this is meaning one, appreciation. Part two, the list. And in this part, remember, mentors will work in at least one of these three puzzles, which are a beast family, Paint It, and disconnected. So let's talk about painting. We want to paint several toy trucks, all equal, as in the pictures, and each truck is made out of several, one by one by one, so unit cubes. Each can of paint will cover an area of 4.3 square units. So before jumping to the puzzle, I think it's important that you recognize what your students would like in terms of art, or what toys they like, or what buildings, solid structures. Discuss a little bit about what surface area means. So, introduce the problem. If you like actually painting things, you can bring some object to the meeting, or even some picture, and show some cool way of painting. It's all about starting a discussion or a conversation about what what in the world, or what in the real life of these students, of your students, and also your fellow mentors, has to do with surface area, with painting, with toys, etc., hobbies. So let's look at these trucks. Here's a fun way to look at it. So we have this website that you could also show to students if you have a laptop during the meeting, which is called Toy Theater/Cube. And here it's made my cube. And you can use symmetry to count not the number of cubes, but the surface area. So that may be the first misconception, that this problem is about volume, but it's actually about area, about painting this surface. And how would we paint that? So how many unit squares would we take? We can see here, for example, that this part that you can see, so this part of the truck would have an area of 3, 3, 3, 3, so that's 12, plus 3 more, that's 15. Then you can use symmetry and say, okay, 15 here, also 15 here, so that's 30 square units. Then you could count, all the top, that would be 8 plus 2 here. And then you could add these 6 here, and finally count the bottom. So you can do this with mental math, or start writing some numbers, and this bottom would be 12. And so let's look at it in the manual. There's several ways to count it, and you shouldn't just impose one way. So in the solutions of the manual, we counted the front part, which is like a stair, and it has 10. So these 2, 4, 6, 8, 10. So this stair, like the front of the truck, that's 10. The top is 8, 2 times 4. The back of the truck, you don't see it here, but it's 6. The bottom is 12, and then the sides of the truck is 30. And so if you add these numbers, you get 66. And then you remember the question is, what is the least number of cans that we need if we want to paint all the surfaces? So it's a division problem, right? Pretty much 66 divided by 4.3 to make sense of that. But here we just use some mental math, some easy way to do it. You just reason like this. For example, 10 buckets will cover 43 square units. 5 more cover half. And then if I add 15 buckets, we'll cover 64.5. So we're almost there. You need 1 more bucket, right? Because the area is 66. And with 15 buckets, you almost get it, but you don't. So some paint will be left. And then the second part is, what is the maximum number of trucks that we could have if we want to be able to paint their surfaces completely with a total amount of 100 paint buckets? So it's kind of a reverse situation. Remember, we're trying to minimize, right? So here, maximize, sorry, we're trying to find the maximum of the minimum. So here's the thing, we have 100 paint buckets, or 100 cans. And the question is, how many trucks can we paint? Maximum, of course. So here we can do some maths. It's simple calculations. 100 times 4.3, that gives you 430. And then we would see how many groups of 66, right, fit into 430. And so here's here's the answer. 6 is the maximum number of solids that we can paint using 100 paint buckets. We can, you can just, don't just jump into the formula or the division, but just play a little bit with estimations. So 10 would be too much, right? Because it would require, 660 square units, and you only have 430. 6, you can do 66 times 6, which is 396, less than 430. So you still could, maybe you have some more, but then you realize that 66 times 7 is adding just one more of 66. And so this is a good math of multiplications, right? That if you have already, 66 times 6, in order to compute 66 times 7, you just need to add another 66. And then you get that 462 bigger than 430. So 6 is actually the maximum number of solids or trucks that you could paint. Remember, last thing, question number 3, don't skip it. Design your own 3D object. And kids may have plenty of options. They could actually draw it, in a paper, the 3D, or they could draw the, the faces. How does it look from the top, from the bottom, from the sides? Or they could also, some of your students, use your laptop or even, their cell phones, or even in the projector, right, in the big room, to actually use this website and build their toys, or any construction. Here, let me say a few things. You could use different colors, of course. You could also delete, or and have students use a lot of symmetry, so that the counting is a little more interesting mathematically and not just one by one, so that you can duplicate or triplicate things like that, and that may be easier. Of course, the simplest case would be if you actually, let me restart this. If your favorite toy is just a cube, because if that happens, if the toy you're making is a cube, then let's do it real quick. So let's do it here to make this cube. Let's make a cube, say, for a 4 by 4 by 4. So here we have the cube. And let's keep, making some layers. If you have this 4 by 4 by 4. Okay, so I have this base of 4, and then I have to keep adding layers, right? Just to make my cube. Then the surface area, it's pretty, pretty symmetric. You can easily calculate it without even knowing the formula by heart of the area of a cube, but just reasoning with some symmetry. Okay, let's see if I made almost there. One more layer, one to go. Of course, this also, enhances the skill, the visual or space skills from students that maybe they're not too used to doing this at school, right? Of drawing or building, building structures. You can also connect it to architecture, engineering, or other fields, right, that have to do with these designs. And then you can, of course, reason that, well, I see the same thing everywhere, right? That's pretty much a cube, no matter how you move it. Similar to a sphere, but, not as cube. No matter where you see it, you always see a 4 by 4. And so the surface area has to be 16 6 times, right? So you can play around with that. And maybe make it a little more interesting, just adding this and saying, okay, what happens? What's the new surface area? How many more? And you'll see that it's actually 8 more because you added these sides here. So 2, 2, 2, 2. So this reasoning of surface area is what really it's the main goal of this puzzle. Just have students be very comfortable with surface area, solving a puzzle about minimizing and maximizing. So again, you don't have to pick this puzzle, but if you pick it, hopefully this video will help a lot. Enjoy the meeting. Bye-bye.